the solutions from exercise 4.3 from the chapter Quadratic Equations. So in the first question, they've asked us to find the nature of the roots of the following quadratic equations, and if the real roots exist, we need to find them. So in order to know the nature of the roots, we need to find the discriminant. The discriminant can be found using the formula b squared minus 4ac. If the value of b squared minus 4ac is equal to 0, we can say that the quadratic equation has equal roots. If b squared minus 4ac is less than 0, then it does not have any distinct roots. If b squared minus 4ac is more than 0, then it has two distinct roots. So using this, we're going to find the value of b squared minus 4ac for all the given quadratic equations, and if b squared minus 4ac is greater than 0, then we can say that the quadratic equation has real roots, or if b squared minus 4ac is equal to 0, it has equal roots. And if so, we need to find the roots of the quadratic equation using the quadratic formula, which states that negative b plus or minus root b squared minus 4ac, which is the value of the discriminant, divided by 2a, which will give us the roots of the quadratic equation. So in the first question, they've given 2x squared minus 3x plus 5 is equal to 0. We can say that the value of a in this quadratic equation is 2, the value of b is negative 3, and the value of c is 5. So we're going to find the value of b squared minus 4ac for this quadratic equation. B squared is negative 3 squared. So negative 3 squared minus 4 times a, which is 2, times c, which is 5, is equal to. So negative 3 squared is 9, minus 4 2s are 8, and 8 5s are 40, which is less than 0, as the answer will be negative. This suggests that this quadratic equation has no real roots, as negative 31 is less than 0. So the second question is 3x squared minus 4 root 3x plus 4, which is equal to 0. Here, the value of a is 3, the value of b is negative 4 root 3, and the value of c is 4. So b squared minus 4ac. So minus 4 root 3 squared minus 4 times 3 times 4 is equal to. So negative 4 root 3 squared would be 16 times 3, and negative 4 times 4 will give us negative 16 times 3, which is equal to 0. So obviously 16 times 3 minus 16 times 3 is equal to 0, as 6 3s are 18, 3 1s are 3, 48 minus 48 is equal to 0. Hence we can say that this quadratic equation has equal roots, as the discriminant is equal to 0. So we're going to find the roots, two equal roots for this quadratic equation. We're going to find that by using the quadratic formula, which is negative b plus or minus root 0, as the discriminant was 0, over 2 times a, the value of a is 3. So negative times negative becomes positive, so you will get 4 root 3 and plus or minus root 0 is 0, so positive 4 root 3 over 6, and we're going to cancel this, so we'll get 2 root 3 by 3, so 2 root 3 by 3 is the two equal roots for this quadratic equation. In the third question, the given quadratic equation is 2x squared minus 6x plus 3. the value of A will be 2, the value of B will be negative 6, and the value of C will be 3. So B squared, which is negative 6 squared, will be 36 minus 4 times A, which is 2, and C, which is 3. So 36 minus 4 2s are 8, and 8 3s are 24, which is equal to 12. Since 12 is greater than 0, we can say that this quadratic equation has two distinct roots. So now we're going to find these two distinct roots using the quadratic equation, which is negative b plus or minus root 12 over 2a. Value of a is 2, so 2 times 2 is 4. We can also write 12 in a different format, root 12 in a different format. Through long division, we're going to find out the prime factors of 12. So 12 can be written as 2 root 3 over 4. So the two roots for this equation will be 6 plus 2 root 3 by 4, comma 6 minus 2 root 3 by 4, which are the two roots for this quadratic equation. Moreover, we can simplify this as 6 and 2 have 2 as its common factor. So we're going to take 2 outside the bracket, and inside the bracket we'll have 3 plus root 3 plus root 3 by 4, and here you'll have 2, 3 minus root 3 by 4. We can cancel this and this over here, which will leave us with 3 plus root 3 by 2 and 3 minus root 3 by 2 as your final answer. In the second question, they're asking us to find the values of k for each of the following quadratic equations so that they have two equal roots. So they're saying that the two quadratic equations have equal roots. And if two quadratic equations have equal roots, that means its discriminant will be equal to 0. So basically b squared minus 4ac for both the quadratic equations will be equal to 0. So in the first question, the value of a will be 2, the value of b will be k, and the value of c will be 3. So they've already given that b squared minus 4ac is equal to 0. With this, we are going to find the value of k. So k squared minus 4 2s are 8, 8 3s are 24, is equal to 0. So k is equal to 24 plus or minus root 24. Root 24 can be written as it's in a different way, so we need to find its prime factors. So root 24 can be written as plus or minus 2 root 6. So the value of k is plus or minus 2 root 6. In the second equation, we have to simplify this to bring it into a form of a quadratic equation. So when we multiply kx times x minus 2 plus 6 is equal to 0, we'll get kx squared minus 2kx plus 6, which is equal to 0. So the value of a here will be k, value of b will be minus 2k, the value of c will be 6. So b squared, which is minus 2k squared, minus 4 times k times 6, which is equal to 0. So minus 2k squared would be 4k squared minus 6 4s are 24k, which is equal to 0. Now we'll notice that these two terms have the values k and 4 as its common factor. So we're going to take that outside. So we'll have 4k, k minus 6, which is equal to 0. So we can say the two factors of this quadratic equation will be 4k is equal to 0 and k minus 6 is equal to 0. So the value of k will be 0 and the value of k can also be 6. So k is equal to 0 and k is equal to 6 are the two values of k. In the third question, they're asking us to find out if it's possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 meters squared. And if so, we need to find its length and its breadth. So they've given that the length is 2 times its breadth. And they've given that the area of the rectangle is 800 meters squared. So we're going to substitute the values of the length of the rectangle in the formula to find the area of the rectangle, which basically is 2b squared, because you're multiplying 2b times b, so you'll get 2b squared is equal to 800. We're going to bring 2, which is multiplication, over to the right hand side. It'll become division, so b squared is equal to 400, as 800 divided by 2 is 400. So b is equal to root 400. We know that 400 is a perfect square, and 20 times 20 will be 400. So the value of b can be plus or minus 20. Since the value of b is length, it cannot be negative, so we're going to take the value of the breadth to be 20, and the value of the length of the rectangle is 2 times its breadth, so it will be 40 meters. In the fourth question, they're asking us, is the following situation possible? If so, we need to determine their present ages. So the given situation is that the sum of the ages of 2 friends is 20 years. So we're going to take the value of the age of the first friend as x and the age of the second friend as y. So the sum of their ages is 20. And 4 years ago, the product of their ages in years was 48. So they're saying 4 years ago, which is x minus 4, and y minus 4, it was 48. So the product of their ages 4 years ago, which is x minus 4 and y minus 4, was 48. We need to find out if this situation is possible, and if so, we need to determine their present ages. We're going to write the age of the second friend in terms of the age of the first friend. So we can write y is equal to 20 minus x. So we're going to substitute the value of y in this equation, which will give us x minus 4 times 20 minus x minus 4, which is equal to 48. So when we further simplify this, we'll get x minus 4 times 16 minus x, which is equal to 48. So when we multiply within the brackets, we'll get 16x minus x squared minus 64 plus 4x, which is equal to 48. We're going to bring 48 to the left-hand side. We'll get minus x squared plus 16x plus 4x minus 64 minus 48, which is equal to 0, minus x squared plus 20x minus 112 is equal to 0, and we're going to multiply this with a negative sign so that it will be easier for us to calculate. So we'll get x squared minus 20x plus 112, which is equal to 0. Now we need to know if this quadratic equation has a solution. So we're going to take the value of a as 1, b as negative 20, and c as 112. b squared, which is negative 20 squared, is 400. minus 4 times 1 times 112. So 4 times 112 is 448. So negative 48 is less than 0. Hence we can say that this quadratic equation does not have distinct roots and the following situation is not possible. In the fifth question, they've asked us if it's possible to design a rectangular park of perimeter of 80 meters and an area of 400 meters. If so, we need to find the length and the breadth. So we're going to assume that the length be x, and they've given the perimeter of the rectangle as 80 meters. We know that the perimeter of a rectangle, the formula for the perimeter of a rectangle is 2 times L plus B. So if we take 2, so we know that 2 times L plus B is 80 meters. We're going to take 2 over to this side to isolate the variables. So we're going to get x plus b is equal to 40. Now we're going to write the value, the breadth in terms of length, so that we can write the quadratic equation in a single variable. So we can write b is equal to 40 minus x. Now they're asking us to prove if it'll be possible to build a rectangular park of area with an area of 400 meters squared. So the area of a rectangle is length into breadth. We know that the breadth is 40 minus x and the length is x. So the area of a rectangle would be 40 minus x times x is equal to 400. So when we multiply the value of x within the brackets, we'll get 40x minus x squared is equal to 400. We're going to rewrite this so that it's in the form of ax squared plus bx plus c. And we're going to multiply it with the negative value so that it will be easier for us to calculate. Now we need to find two values in which its sum will be negative 40 and its product will be 400. Two such values would be negative 20 and negative 20. Substituting the values in the quadratic equation, we'll get x squared minus 20x minus 20x plus 400 is equal to 0. We're taking the common values outside, so we'll get x minus 20 minus 20 x minus 20, which is equal to 0. So the two values would be x is equal to 20 and x is equal to 20. So this quadratic equation has equal roots. And since we know that x is the value of the length, we know that the breadth of the rectangle is 40 minus x. So the breadth will be 40 minus 20. So the breadth is 20 and the length is also 20.